Now let's implement the remove operation. This one is going to be a little bit more tricky because there are a few different edge cases that you need to count for. So let's declare a new method, public void remove. We don't need any parameters here because we always remove the root node, which holds the largest value. So the first thing we should do here is to move the value of the last node into the root node. That is very easy. We set items of 0 to items of size -1, and then we decrement size by 1. Or we can combine these two lines into something like this. So first, we decrement the size field by 1. Now we can use this value as the index of the last item in our heap. Okay? Now, once we remove this item, we should execute the bubble down operation. So if this item, that is what we have currently in the root, is smaller than its children, we need to bubble it down. And we keep repeating this until this item is in the right position. So here we need a while loop. While this item, well, we don't want to hard code 0 here because in every iteration, the index of this item is going to change. So let's declare an index variable and set it to 0, and then use it over here. So while this item is smaller than its left and right children. So here we need two separate methods for calculating the index of the left and right children. That is very easy. So private integer left child index. We give it an index, and here we return index times 2 plus 1. We can also duplicate this and rename the second one to right child index. And here we should add 2 to the result. Okay, now back to our remove method. If this item is smaller than items of left child index of this index. So if this item is smaller than its left child, we could also extract this into a separate method because it's getting a little bit too convoluted. So I would create a separate private method, left child, which gets an index. And here we return this expression. There you go. So if the current item is smaller than its left child, that is better. And this item also is smaller than its right child. Now we don't have this method yet, so let's create it over here. Private integer right child. We give it an index, and this will return items of right child index of this index. So if both these conditions are true, that means we're dealing with an invalid parent. Again, we can extract this logic into a separate method called isValidParent. So let's create that over here. Private boolean isValidParent. We give it an index. Now, a node is a valid parent if it's greater than or equal to both its children. So when moving this expression over here, we should reverse the conditions. The current item should be greater than or equal to both its children. And now we return the result. That is better. So if the item that we have at the current index is not a valid parent, that means we have to swap it with one of its children. But which one? The larger one. So now we need to figure out which child is larger. That is very easy. We can use our helper methods. So we can declare a variable called larger child index. Now here we use the ternary operator. So we add a condition. If the left child of this index is greater than the right child of this index, let me put this on a new line so you can see clearly. So if the left child is greater than the right child, here we add a question mark. If this condition is true, we're going to set the larger child index to left child index of this index. I know that sounds weird to say, but let's not get hung up on this. Otherwise, we set the larger child index to right child index. Now that we have the larger child index, we can swap the current item with its larger child. So we call swap and give it this index as well as the larger child index. Once again, let's refactor our code and move this logic into a separate method. So let's declare private integer larger child index. We give it an index. And now we can move this logic, this ugly logic, inside this method. And finally return the result. So with this, we can clean up our remove method. Here we call our new method, give it this index. Then we swap the items. And finally, we reset the index to the larger child index, because we're going to continuously bubble down this item if it's smaller than its children. Now, during this bubbling down operation, in every iteration, index is getting larger. So at some point, it may fall outside the valid range. So here we need another condition. If index is less than or equal to the size, and the current item is not a valid parent, then we're going to bubble it down. So here's our remove method. Now there is something missing. What if the heap is empty? We want to throw an exception. So if size equals 0, we're going to throw a new illegal state exception. Again, we can extract this logic into a separate method and make this code more expressive. So I'm going to declare a public method, public boolean is empty. Here we return size equals 0. I made this public because we may need to call it from the outside. Okay, so now I'm going to remove this expression and call the isEmpty method. That is better.